on your machine. You can download the binary, or you could use Docker or a virtual machine, but we're going to be looking at the cloud alternative. So one component of the MongoDB cloud is MongoDB Atlas. So this is the cloud version of the MongoDB database with a little bit of extras. So one advantage of using this is, well, now you don't have to worry about managing your own server. So it's not that managing servers are particularly difficult, but it is a time-consuming process, and you want to make sure that your servers are secured as possible. So by using the cloud-based option from MongoDB, you eliminate a lot of that stress. Now, there is a forever free tier. So you can go to the MongoDB cloud, which I'll show you shortly, and spin up an M0 cluster. You'll never need to enter a credit card, and it's pretty powerful. You can actually do a lot, and you'll probably never need more than that, at least for this particular hackathon that you're participating in. But if you find yourself needing to scale, there is easy scaling in MongoDB Atlas. So you could always scale your cluster up or down, depending on demand, with a few clicks of the mouse. Another side of the MongoDB cloud is Realm. So when it comes to Realm, a lot of people think that, hey, I know that's the mobile database that I typically see with iOS and Android, because it's a replacement to SQLite and Core Data. That's true. MongoDB acquired Realm recently and have expanded it beyond just the mobile offering. So this is the MongoDB Realm for the MongoDB cloud. So one offering that Realm offers is serverless functions. So these are kind of like Lambda or what Netlify offers or Azure. There's a lot of different offerings that are in a similar space, but this eliminates the need for you to develop your own backend. So hosting your own backend. So you're instead developing functions and triggers, which are called as needed. And instead of hosting a backend application full time, you are now paying for usage. And there is a free tier with Realm as well. In addition, there is mobile sync. So when you're developing your mobile applications, you're using an offline first approach. So when there's no internet, you're saving locally. When you're able to sync, it'll sync to MongoDB Atlas. So that way you get a very nice experience. And then there's GraphQL. And by no means are these three the only features of MongoDB Realm. Just like in the previous slide, the 3 bullet points were my 3 favorite items. They're not the only features of MongoDB Atlas. But GraphQL is one of the newer features. So let's say that you have your documents, you have your collections in MongoDB, and you want to spin up a GraphQL API, but maybe you don't want to develop it. So at Realm, you can actually deploy a GraphQL API without actually writing any code. So you can define which collections and which document fields will basically map to GraphQL fields in queries and mutations. And you can define certain permissions and rule sets on who can access such fields very easily without any code. So it's an option to look at if you're developing an API. So we're going to look at spinning up both, and then we're going to get into the code side of things. So starting with Atlas, this is what you'd get after you create an Atlas account. So this is one cluster already deployed, and you'd have insight into it as well as you can view your data as well. So to get there, the first step in deploying a cluster on MongoDB Atlas is to pick your cloud provider and region. Now, it's not what you think. It could be a little deceiving. You're not actually picking AWS, Google Cloud, or Azure because that's where you want to manage your cluster and that's where you want to receive your bill. It's not like that. Instead, it has to deal with latency. So let's say that you are already hosting your backend applications on Azure. Well, it probably makes sense to also host your database on Azure as well because of the distance between Azure servers. It'll give you the best performance. You will never have MongoDB on your Azure bill, and you will never have to manage MongoDB through the Azure dashboard. It'll always be through the MongoDB cloud dashboards. So once you pick your region and the cluster size that you want, in this case, for a lot of people, will be M0 because that's the free cluster. You would then pick some database users. So you would need to lock down your database on a as-needed basis. So for example, maybe you have an application, which we're going to create shortly, and we want to create a database user for that application. So we would create one. It would be, say, for HackNC database, and we give it access to only those collections. Now you could, it's like any other user account. You can give it permission to multiple databases, multiple collections, etc. But you probably want to be secure in how you're designing your infrastructure, because you don't want any kind of malicious activity by accident. So you have the options here. After you add your database users, you also need to define access rules for IP addresses. So by default, nobody can access your MongoDB Atlas database. The only way to access it is through the web dashboard that you currently see in the screenshot. If you want your application to be able to access your database, you need to add the IP address of that host. You could add your current IP address. If you're prototyping, you could also add 0000, which will open it to all IP addresses. But I don't recommend you doing that unless it's strictly for prototyping purposes, because opening it to the entire internet does introduce a whole new set of risk. But hopefully your databases in that circumstance they still have user accounts associated to them. After that, you're done. It's just a few short steps. You can get it done in like a minute or two. But once you're done, you can view your databases and collections. You can view the data in those. You can do simple queries. You have all kinds of metric information. You can use all the different profilers that exist, a whole lot of power. And you're not restricted to just accessing all of this through the Atlas dashboard. If you're more comfortable with the CLI, go for it. I, for example, love the Visual Studio Code extension. So that's how I usually interact with my clusters. You can use Compass, you can use the drivers, whatever you feel the most comfortable with. Now on the Realm side of things, so assuming that you have an Atlas cluster deployed, you would say, click on that Realm tab and create a new application. You would say this Realm application is going to use such and such cluster, and you're brought to this screen. And there's a whole lot you can do here. You could do GraphQL, you can do functions, triggers. You could do static website hosting if you want. There's a whole lot that you can do in Realm. But what we're looking at and what we're going to see code for is we're going to see it inside of webhooks and serverless functions. So you would say third-party services, you would choose HTTP, you would give your service a name, and then you would define, well, what webhooks do you want and what functions do you want to go with those? And I see a question coming in. What if your server apps are behind a load balancer? How do you specify IPs to allow? I assume that you still have static IPs associated under that load balancer. DevOps is definitely not my strong suit, but I'm guessing that it's not going to just randomly create IPs out there. You're going to have a set. So you're going to want to add however many servers are inside of that cluster. But again, definitely not an expert when it comes to DevOps. Good question though. So this is a webhook. In this case, I'm calling it get all. You can call whatever you want. We're going to see some code behind this in just a minute. But in addition to configuring that webhook, so the webhook would be what the user can interface with, and then the function that actually has the logic. So this is similar to Lambda and API Gateway if you're thinking in terms of AWS. But in Realm, it's all built into one. And you would define that webhook. So the post, get, put, delete, whatever type of request you're looking for, and the function code that goes with it side by side. So let's start looking at some data modeling. So before we even jump into some queries and how to interact with that data, we probably want to understand the data that we're working with. And I thought that given kind of the type of event that we're at, I figured maybe school and student data might be appropriate. Now, this is all very fictional, so don't think this is a real example. I made it up off the top of my head. So let's say that we have school data and we have student data. If you wanted to, you could have two collections. So collections are groupings of similar documents, document types. So for example, all school documents might exist in a school collection and all students might exist in a student's collection. And they could look like this. This would be a very basic document. You're working with JSON data here, which is stored in the database as BSON, but JSON can be very complex. It doesn't have to be flat like this. But take note of the IDs in this example so far. I'm going to walk you through it, a few examples when it comes to data modeling. Let's say that we wanted to use a more relational approach to our data. Let's say that we have a school document, and inside of that school document, we have a students array. The students array contains IDs for particular student documents in the student collection. You could do this in MongoDB. There's a lookup operator, which acts kind of like a join, like you'd see in a relational database. It's perfectly acceptable. But with this particular scenario, we may one day end up with very large documents. So I'm going to throw out some random numbers here that make no sense at all. But let's say that each school gets 50,000 new students a year, and you're collecting 100 years worth of data. Well, that particular document, even if you're just storing short strings like that, it's going to get large. And there is a finite limit to the size of a document in MongoDB. The larger the document, potentially more poor performance. And if you really want to do that relational approach, if you're stuck on doing the relational database aspect, well, maybe you might consider not using MongoDB and going to a relational database instead, because maybe it's best suited for your particular needs. Or we can look at changing how you're modeling that data to be better suited for MongoDB. So let's look at another example. So now we're not looking at any kind of relationships in this particular document. We still have this school document, but we've modified it slightly. It might actually look a little worse. But now instead of a students array, we have a students object, and that object has years. And then for each year, it has an array of student objects. Now, these student objects, they could be much more complex than this. It could have address information, who knows? So this introduces potentially other problems. So one, it might be pretty unmanageable down the line. So like with the other example, if you're facing 50,000 new students a year and they are structured similar to this, you're going to have some pretty crazy documents here. You could have, again, large documents, probably much larger than the previous example, which might lead to poor performance. And even though you can query arrays and objects in MongoDB, the more complex you get, the more complicated it might become. And that's all honesty. So let's look at another example on how we can model this same data. Let's say we kind of flip-flop the idea. Instead of having a school document, we have a student document. So inside of the student document, we have a school. Now, a student may have multiple schools, but they'll probably not have 50,000. And these documents will maintain fairly non-complex look to them. So what do we face with this? Well, there's the potential of duplicate data, because now every student who's enrolled in University of California, Merced, well, they're all going to have that same information. But that's all right in a NoSQL database. Having duplicate data is fine. Disk is cheap. And if you're truly going to access this data alongside your student data, it probably makes sense. You can get this in one single request rather than having to do any kind of multiple lookup operations or just using the lookup operator. It's better, in my opinion. So these are smaller documents, easier to maintain. If you really wanted to, what you could do is you could still have a school document with an ID, and you could store a subset of that school information inside of the student and include the ID. So that way, if you really wanted more information or information that might be subject to changing more frequently, then maybe you still do some kind of relationship and have part of it inside of the student document and then the rest of it inside of its own document. Now, there are probably 100 different ways that I didn't explain here on how to model this particular set of data. There are a lot of options that you have. I actually did a Twitch stream recently with my colleague Lauren Schaefer on some anti-patterns for MongoDB document models. I've done other Twitch streams on the subject as well. I encourage you to watch them on demand. It'll definitely help you for this particular event. And you can always look back at this at a later time as well. Just a reminder, I am looking at the chat. So if you have any questions, please stop me because I want to make this an interactive experience. So let's get into CRUD. So we have a general idea on some of the ways that we could model our data. But of course, that could always change. And even if we picked one of those other ways, it could still change in the future. So let's look at some CRUD operations. So the first stage of CRUD would be create. We want to create some data. And this is using pretty much the CLI. So if I were to run this personally, I would run it in my Visual Studio Code using the MongoDB Playground extension. It doesn't really matter how you run it, but this is not direct code that you would see in a Node.js application, not yet. So what we're saying here is we're saying we want to use the workshop database. Then we're saying that we want to use the students collection inside of that database. We're saying InsertOne, and we're providing it an object. We're doing this 3 times for 3 different students. So this would create 3 different documents as long as the ID field is unique. It doesn't already exist inside of your collection. Now, let's say that we want to insert all 3 of these at once. We don't want to do 3 different operations. So what we can do is we can do an insert many. So instead of passing in one object, we're now passing in an array of objects, and it will insert all items in the array in one go. As a response, you'll get a list of the IDs back that were inserted, so an array. And likewise with the previous command, you'd get the ID that was inserted back as well. You'll see that for each one of these CRUD operations, there's a one and a many operator. So you have the options to choose. And a lot of this will be similar for each one of these steps. So you may, I don't know, roll your eyes that this is too easy. The point I'm trying to prove in each one of these is that there's a few different operators that you can make use of. And that's what I want to show. So that way you can look back on this material for the event. So let's look at the FindOne. So the FindOne, what we're saying is we want to pass in an object which acts as our filter. So in this case, we're filtering by the ID, which is a unique field. And we're saying that as long as documents match that particular filter, let's go ahead and return that one document. We'll only ever find one document, regardless on if we chose to find one, because we chose to use the underscore ID. What we could also do, if we didn't want to do an exact match, we could do a ranged query. So a ranged query, what we're doing here is we're saying the GPA has to be greater than, so $GT is an operator in MongoDB, and we're saying greater than 3.5. Now there could be documents, there could be multiple documents that meet that criteria, but because we're saying find one, it's only going to return the first one. And I noticed that there was some chat going on inside of the Discord earlier about the use of Mongoose. So I'm not actually going to be using Mongoose in this particular session. So this is all going to be vanilla MongoDB and the vanilla MongoDB Node.js drivers. So you're going to see that, you know what, maybe you don't necessarily need Mongoose for your applications. So let's take a look at another example. So this is find, so find many. In this example, which is, again, like I said, very similar for each one of these. I'm just showing different filters that you can use, different operators that you can use. But for this, we're saying find, the graduation year has to equal 2010. And the GPA has to be greater than 3.0. For any document that matches, we're going to get an array of documents back. So just like that. Now you could do OR operations as well, but just by doing a comma separated list of fields, that's going to be the AND operator. So you can refer to all of this in the documentation that MongoDB has. Let's take a look at UpdateOne. And trust me, we're going to get into some actual Node.js code shortly. I just want to make it so that way you can understand each of these different operations, which will be used quite frequently in a real application. So the UpdateOne, it's similar to the find and similar to an insert in the sense that the first part of this, the first object is the filter. So we're filtering in this case by the unique ID. So if we find one document in that case, if one document matches, then we're going to use the modify criteria. So in this case, we're going to use the set operation, and we're going to set the first name and college fields. So if first name or college exists already, that field will be replaced with whatever we haven't set. If that field doesn't exist, so let's say college did not already exist in that document because it doesn't need to be, it's a NoSQL database, it'll go ahead and add that field to the document. It won't just fail. Here we have update many. So this is another operator. So the filter, a little more complex. We have two different criteria that must be met. We have the graduation year and the GPA. If documents match, it could be more than one. We're going to use the push operation. So push will add values to an array within that document. So we don't need to first find that document, do the manipulation, and then push it up in several operations in our client-side code. We can do it all in one. But in this case, we would add honors to the awards array. So maybe we're doing a some kind of operation on our database where certain students are now on the honor roll because of their grades. So we're pushing honors as kind of an achievement. Delete one pretty much follows the same trend here. I'm choosing to delete based on the ID. It could be any field within the document. All right. Sorry, I'm just peeking back at the chat every once in a while. If this command is successful, it'll say the deleted count, which will only be ever 0 or 1. Likewise, the delete many. Here's a different operation here. We're saying delete any document that has honors in the awards array. Doesn't matter where honors appears in that array. As long as it's there, that document will be deleted. And if I go back a few slides here to the update many, the push operation will actually just append it to the end of the array. If you're looking to check for a uniqueness in your array, like if honors already exist and you don't want to add it twice, you would use a different operator for that. So you would use something like add to set. And there are quite a few operators that you can use in MongoDB. So let's look at some more. So let's say that you've done your CRUD, you've done your filters, which your find operations, which accomplish quite a bit of common needs. But let's say that you need to do something a little more, and you don't want to do a lot of client-side application coding. So you can actually use the aggregation pipeline, which is kind of how it sounds. So you have stages in a pipeline, and each stage gets executed in order of that pipeline. And those pipelines can grow however long you want them to grow. So let's look at the first example. Let me get a drink first. So this first example, we're using the aggregate command. And each object inside of that array is a stage in the pipeline. So this first stage is going to be a match. So kind of like what we saw with the filter. So we're matching for any documents that have a graduation year of 2010. For any documents that match, they're going to go on to the next stage of the filter, or the next stage of the pipeline. In this case is a group. So in this case, ID is a required field for the group operator. And what we're saying is those are the fields that we want to group on. So the major and the graduation year will be a group. And then we want to do any kind of aggregation on that particular group. So for example, the sum, what we're saying is we want to total however many people appear in that group. And then the average, we want to calculate the average GPA of anyone who appears in that group. Fictional story right here on how maybe this could be useful, totally made up. But let's say that you are business analysis at your university, and you want to get a report for how every major at your university is performing for a certain year. So you do this and you notice that, hey, the mechanical engineering major is performing very poorly. So maybe you pass this information along and more planning is in place to improve the GPAs of all the students that are in that cohort. Again, fictional story, but it could be useful. So let's look at another operator. So this is not an actual pipeline, but I wanted to explain the unwind because it probably wouldn't make sense in the next slide if I didn't explain it prior. So unwind is used to flatten arrays inside of MongoDB documents to make querying a little easier. So let's say we have a document on the left. It has a courses array, which has objects. And we want to flatten it so that way we can access and query, say the document by the name or the grade without having to do some kind of complex array operation. So we do an unwind, and what it does is now we have two documents being returned in that operation. So each item in that array is flattened and merged in with the parent data. So that way, instead of a courses array, we have a courses object, and we can just use dot notation when querying. So how that might look, let's say we want to do a match, unwind, and then another match. So we match for a particular document, so one particular document. Then we flatten the courses with an unwind, and then we do a match stage on the grade. So we want to find all of the instances where the grade is an A or A plus. So it would return basically true or whatever you wanted to return, but it would be a little slightly different than if you were to try to work with that data inside of an array. And these are probably very small aggregation pipelines. They're not too complex compared to what you could do with them. There are a lot of different operators. Like I mentioned, there's a lookup operator where if you have two different collections, you could do a lookup to kind of do a join like you would in a relational database. There's other operators. I've only used a handful of them based on my needs. Maybe you want to use a union, but it's totally up to you. Looks like my tablet went into standby here. Just make sure that there's no questions coming in. All right. Let's go ahead and look at the next. So let's take a look at adding it to Express Framework. So we're going to take what we know about CRUD, and we're basically going to create API CRUD endpoints. So post being create, get being read, put being update, and delete being delete. So let's take a look. So this is Boilerplate Express. This is going to be common for, I'm hoping, every Express Framework application. Maybe people are doing it a little more extravagant than me. I'm not sure. But you basically include each of the Express dependencies. So body parser would be for sending payloads with your requests. So being able to parse those cores if you're operating on different hosts between your front end and your back end. And then a bunch of endpoints followed by a listen. You're going to listen for requests on a certain port. Now, if you want to include MongoDB, if you want to connect to MongoDB, you might add this. So assuming that you've already run npm install MongoDB, you can import the Mongo client. And then you'll notice towards the middle, we have a new Mongo client that's using an Atlas URI. So the Atlas URI comes from Atlas, the Atlas dashboard. You would click the connect button and it would give you the string that you're supposed to use. I'm using process.env because I don't want to hard code that value in my application because I don't want certain people to see it maybe. I don't want to commit it to GitHub because it does include a username and password in it. So it's safest if you store it in an environment variable and use it that way. Now, let's go ahead and continue. So we have the collection. So the collection, we're actually going to set it inside the listen function. So that way we can use it inside of each of the endpoints. So inside of that listen function, what we have is we have a connect. It's an asynchronous event. But once we're connected and it doesn't catch any kind of error, we're going to get the collection from, say, the workshop database and the students collection. So that way we can use it going forward using that global collection variable. Now, to actually use this in API endpoints, it's going to be very similar to what we've already seen. So we have a post endpoint, a get, a delete. We have collection.InsertOne, collection.FindOne, collection.DeleteOne. It's the same usage scenario that we saw with the previous slides, which were just CLI commands or Visual Studio Code Playground commands. So each API that MongoDB offers, it's going to be pretty much the same between languages. So whether you're using Node.js or the CLI or Go or C#, they're all going to be very similar. With the exception that certain languages have just different ways that you handle things sometimes. What you'll notice here, though, in these endpoints are that for example, in the post endpoint, I'm taking the request body and I'm just choosing to insert it. Now, MongoDB, if you send it JSON, it's going to save it into that collection. It's not going to complain. The problem is that even though that you have the flexibility to store anything, it's probably not a good idea to just throw anything at the database, because long term, when you're making a great application, you want to have some kind of structure in place. It doesn't mean that you can't change that structure in the future very easily. It just means that you should probably have some kind of model thought out. So there's two ways to do this. The first of which is to use an application level data validation library. So you can use something like Joy, which is very popular. So you would create a schema. So inside the schema, you would define all of the fields that might exist for the student's collection. Sorry, the doorbell rang. You would define each of the fields. In this case, all I'm doing here is I'm defining what those fields should look like, whether they be strings or integers or floating point numbers. Joy has very extensive documentation and what it can do. So Joy, for example, maybe you want to validate based on regex. Maybe a certain field should be an email address. You have a lot of options with Joy in terms of validating the data that's coming in. Now, to use it in your endpoint, you can see on the right that I'm saying schema.validate async. I'm passing in the request body. It's going to compare it against the schema, make sure everything checks out. And then what I'm going to do, as long as it doesn't throw an error, I'm going to use that validation data in my InsertOne. I'm not using request.body because, you know what, Joy might do some manipulations at some point. So for example, maybe I pass a string for the year. Say, I don't know what, there's a bunch of noises happening. Anyways, I'm sorry if the noises are passing into the stream. I honestly don't know where it's coming from. So we have I got to figure out how to shut this off. Hold on. I apologize. I think it's coming from Discord. I'm not quite, there we go. Do not disturb mode. Perfect. Anyway, sorry. I apologize for the interruption there. As I was saying, graduation year might be a string. So what it's going to do, Joy is going to actually turn it into a numeric for us. And that's why I would use validation. The other option is you can use MongoDB schema validation. So for example, when you create your collection in MongoDB, and you don't have to explicitly create a collection, it'll create one for you if you're trying to use it. But if you explicitly create a collection, you can add a validator, and you could specify what fields should be what types. You can use regular expressions. You can say which fields are required, such and such, similar to how you would in Joy. The difference is that this is from a database level. So it does not matter what application level library you're using. The database will catch everything and throw errors if you try to violate. You could use Joy and the MongoDB schema validator in combination. It's fine. It's totally up to you. But you have options. So let's take a look at webhook functions with Realm. So this is going to be a kind of shift. So this is no longer Express, because really with the Express framework stuff, it's all we saw already with the CRUD operations, with the Mongo query language CLI stuff, the data aggregations, the APIs, they carry over. So it's all up to you on using your imagination on how you want to use them. So with the webhook functions, so this is if you don't want to roll your own backend, you can create a function that looks kind of like this for creating. So you go through the process as I showed in the first few slides. For creating a webhook, you would define the path to that webhook, like you would name it, and this is where you would actually enter your function code. So in this case, we're accepting a payload body, which we're converting to text. The command is very similar. I mean, there's a little bit of differences, but in the end, what we're doing is we're saying .insert1, and we are inserting whatever the body was. Now, I don't have any validation code here in this function. We could assume that we have schema validation enabled on our collection, or we can go ahead and use Joy inside of our function as well. It's totally up to you when it comes to user data. Reading data should look pretty similar as well. Here we're using a find operator, and we're using an empty object in there, so an empty filter. So what this is saying is it's going to get all documents within the student's collection. And we're going to convert it to array, and we're going to return it as part of the response body. Then finally, we have update. So update is going to look pretty familiar as well. So we have the ID. This ID, it could exist as part of the query parameters, the payload body. It doesn't really matter. But we're getting the ID so that way we have something to filter against. It doesn't even have to be the ID. It could be any kind of field that we want to filter against for the update. And then we have a set operation based on the body payload. Now, something interesting to note here. So if you are receiving a request from a user for data to update, let's say that you have 10 fields in your document, and the user only sends you one in the request here. It's not going to replace all of the fields in your document. It's only going to replace the field that the user provided, which is good. There are also replace operators in MongoDB. So if you did want to replace everything as far as that document goes, you can. But set in this example will only set fields that were passed. So that could be useful depending on the circumstance. So I wanted to go over a few takeaways, and I'm hoping that referring back to this slide, the slide was submitted to the event, so you should have access to it if you contact the organizers. So you could use everything as a reference for this event. But as far as key takeaways go, and I'm sorry if the screen just went bright on you because the slides were dark previously, but take advantage of Atlas. Atlas is there to make your life easy. You don't need to worry about figuring out your Linux VM or whatever you're doing on premise. Take advantage of the free tier that MongoDB offers. It's very easy to get started with, and you'll have even more features than you would have locally. The data model, I only showed you a few small examples, many of which were probably pretty awful, but there's probably 100 different ways to model your data. If not more, you're going to have to figure out, well, how do you need to work with that data? My suggestion might be figure out what your application is going to be needing in every request. Like maybe you are trying to build an API endpoint for showing the user profile information. Well, maybe all of that user profile information exists in the same document. So that way you only ever have to make one request. So you could very easily model your data that way. The APIs, we saw 3 different ways to work with MongoDB here. We saw the CLI, the Node.js driver, and Realm, and they all had the same functionality. So switching between languages and some of the platforms within MongoDB, you're going to have the same experience or very close to the same experience. We saw Express framework. You could very easily use Happy.js or one of the other frameworks that exist. And if you don't want to worry about deploying your own backend, maybe check out serverless functions and webhooks, because that's a very valid option when it comes to your API, in addition to GraphQL, which Realm offers. If you do go the Realm route, you do have access to certain authentication opportunities. So again, you can authenticate users, you can give users access to certain fields within documents. All of this is built into Realm to make your life a little easier. Here's some resources that you can use during the event. So for example, on Twitch, I stream on Twitch probably once a week, sometimes more for MongoDB. Right now, I've been doing a lot of streaming around game development. So if you're into, say, Unity and MongoDB, maybe tune into the next few streams, which will be on that topic. If you want to learn about use cases or some of the features that MongoDB offers, there's a podcast which I host. The developer portal has a lot of tutorials, community forums if you want extra questions, or if you want to contact me directly, I have all of my social media links inside of my personal website. That is more or less everything that I have. I'll leave the actual resources links up in case you're catching them from Twitch and not from the Discord or the event, but I'd be happy to stick around for any questions. I don't know if we're almost out of time or not, but I'll stick around for a minute. So is there a way to create serverless functions without coupling to specific infrastructure? I'm not quite sure what you mean by that. Do you have an example on why you would not want a couple? Maybe that'll help me identify what the question is. And for everyone who's viewing on Twitch, I'm actually referring to questions that are coming in on the Discord for HackNC. If anyone else has further questions too, please drop. If you drop them in the Twitch, I believe one of the moderators will drop them in the Discord for me. How would you go about hiding secret info like passwords? So typically, when it comes to passwords, you would use something like bcrypt. So bcrypt is a hashing algorithm. You would run it client side, or in this case, through the back end. And so it would hash it and then store it into MongoDB. If there's things that you don't want to hash, maybe, for example, social security numbers. So with a password, you're never going to want to reveal the password, but a social security number, maybe you want to reveal it depending on the use case. You can use field level encryption with MongoDB. So field level encryption will let you define keys and then encrypt certain fields of the documents, which will be complete gibberish inside of the database, but you can actually decrypt them in your application layer. When you are fetching resources. So when you do finds, yeah, I get what you mean here. So get user. So typically you would probably not want to fetch the user, the password. You'd probably not want to fetch the social security number, whatever sensitive. You would probably only want to fetch certain fields. So you could actually use a project. And so inside of the find, so you would say like collection.find, you would pass in your filter, and then you would chain it. So you would add a, I think it's project or projection, and you would define which fields you want returned back with that request. Does that make sense on that particular question? And you can do the same thing with the aggregation pipeline too. You can also define which fields you want to come back and which ones you don't. Because it's not just when it comes to sensitive information. Maybe you've got very large documents and you don't want everything. It will mess up your application latency if you get back 10 megabytes worth of documents on every fetch. So you might want to just limit it to what you need as well. If you want to switch from GCP to AWS or vice versa, unfortunately, those would be all different cloud providers. So, I mean, I'm not sure if serverless framework, the NPM package still exists, but it's basically a vendor locked thing, switching between each one of these platforms. I don't know if there's any kind of migration assistance between them. But that's just from a function level. That's not from a MongoDB level. If you needed to switch from GCP to Azure on Atlas for any reason, I mean, you could easily switch. But functions, the function syntax would be different if you're trying to switch from, say, Lambda to Realm. And not entirely different, just a little bit different. It's still JavaScript. Any other questions that I can help with? All right, then maybe I appreciate everyone coming to my session today. I'll be periodically hopping in and out of the Discord. So if you need any help with your application, please bounce some ideas off me. I'll let the moderators take over from here.